All right, so the notion of application security really comes into play from a standpoint that you have to know a little bit under the hood on many of these different concepts in order for you to be able to A, talk intelligently about it, but then B, apply security mechanisms to these components within software development in order to make sure you're practicing good security. And why do I say that? Well, a lot of times when from a security control assessment team, when we go in and we're evaluating a product or an environment or an application, a lot of times people on your team as an assessor will have very expert level skill sets in particular areas. Usually you have a team lead that will go in and be able to evaluate many of the components. Then you'll have somebody who might be a Windows expert. You might have somebody who's a Linux expert. But those three people are working in tandem to test out the different controls. Many of the times, there are client server architectures. There's web servers that are running. There's databases that are running. So having an eclectic mix of these technologies and a rudimentary understanding will definitely put you in a position where if you understand how these things work, there's a good chance that you could actually secure them prior to an audit, or just for your project's purposes, lock them down. And so being able to understand what these are really comes in handy. And we're going to go through and talk about some of these. All right, so what's the difference, in your opinion? Put it into the chat window if you don't mind. What's the difference between an application really is typically more software driven, but serves a specific purpose? So you can have many applications running in an environment, and really that's what helps with when we are dealing with coming up with an accreditation boundary or security perimeter, that we're trying to figure out what is in the scope of our security that we're responsible for. Figuring out if it's an individual application that maybe talks up to a larger environment, or an environment that has multiple applications that talk up to it. So that's kind of the way I look at it, is typically the applications will run, and I think one of you guys said it here, runs in the environment. So you can have n number of applications running in the environment. So with the client server model, this still exists. And typically what we see here with the client server model is there will be some sort of install that happens down locally on a person's machine, and the install, like an exe or something along those lines, maybe an MSI, something that will actually install and add DLLs to a Windows machine. And inside of that install, it's programmed to reach out over either the intranet or maybe even out to the internet to some server that is accepting those comms back and forth. And so a thick client, if you will, means that you actually install something on a person's machine, and that usually will communicate back to a server. So this would be the client over here, and over across the wire would be the server. Usually the communications here, or these, are done with what is called a remote procedure call. So with the client server, you'll have an RPC, a remote procedure call. That's essentially a lack of a better way to say it, it's basically a lookup or a query or a search from the installed piece of software on a person's machine out to a resource, and it comes back to that piece of software that's installed as a data set. So the remote procedure call goes out to the server. Server sends it back to the client as a data set. Client application will read that data set into the GUI of the installed program and then display it in a way that is meaningful to the end user. And that paradigm that I just talked about has been around for a very long time. And really that model has now evolved to a very similar example with web applications. And I say that because typically with web applications, we see a similar model here. So if I come in here and I get a cylinder here, I just draw a web application here. And on top of my, what I'm going to be putting together here for you is a web application. So we should be able to take the web application here and kind of hopefully bring it to life. I'm going to go ahead and put a world here. And the world is going to denote a web server for me. That's what we're going to call it. Okay. So as I go through and I'm building this out, if you have any questions, then let me know. So a web server in the process of how this works, a web server can be anything like Microsoft Internet Information Server, IIS. You may have heard of that before. The most popular web server in the world is Apache because it's free. And those web servers, essentially, just like the name implies, serves up web pages. So it allows you to have a service that is running that people can communicate over port 80, or if you set it up appropriately, port 443. But in order for them to communicate over a web server, in order for you to serve up web pages or to have a web server running, you have to have a service in Windows for IIS or a daemon in Linux for Apache. And so you can install, and then you can shut down the service or the daemon and kill the web server. So if that's what you choose to do, then nobody would be able to browse your web server. But if I wanted to create a web server, I'd need to have that service running and make sure that that web server is communicating. So innately, just by default, the web server will talk over port 80. Okay? And those web server examples here that I just mentioned are IIS and Apache. Those are the two most common ones that we see. And there's a reason why I'm saying this, because most of the apps that we use, most of the things on the internet that we do, it's all running via web server technology. Now, there's a difference between the different types of tech that's out there. You can have what's called a static website, which means that it does not change regularly. Right? We can have a static website. Dare I say that that's pretty lame? Oh boy, did Ben really say that? The static websites are lame? Yeah, I did. However, in our case, what I'm describing here is that a dynamic website. So the way that a dynamic website changes, it will change on demand, and based off of how you interact with that web application, it will change on demand. But there is one catch here. There is one catch, that a dynamic website attaches to a database. And that is what I have over here, a database. So the cylinder in network diagrams, is connotated as a database. Okay, so I'm going to put this right here. And in order for this to be a dynamic web server or a dynamic web application, then I need to have some sort of connection between my web server and the database. Okay. So I say that because there are some things that I want to show you here, because I think that a couple of you, when I was meeting with you last week, some of you said that this may be one of the more difficult topics for you. Oh, hey, watch out now. That was wonky. All right, so let's say that I have a modern browser here. And this modern browser, for brevity purposes here, this is Chrome, but certainly I could put Safari and Edge in here, but we'll just go with Chrome for right now. So as Chrome is your web browser of choice, what we'll do is we will, in the URL of Chrome, we type in the DNS info of the website. So we don't put in the IP address of the website. We'll put in the URL of the website, because we remember website names more than we remember IP addresses. So that's one of the whole reasons why DNS was created. So we put in the URL of the website, and from there we're able to interact with all sorts of websites all over the world. And in different cases, we may want to interact with a dynamic web server. And because of that, the server has to have the web services enabled and running on there. If it is unencrypted, it will be running over port 80. But if it's encrypted, then IIS and Apache and every other web server that's out there can run over port 443 as HTTPS. And from HTTPS, it's encrypted. So now I have an encrypted tunnel going over SSL or TLS from my browser to the web server. And this is important because if I want to have it be a dynamic web application that changes on demand, I'll need to connect it back to a database here. And this is done a number of different ways. But one of the ways that is uniform is on the web server, there will need to be some sort of connection object telling the web server to go to this specific address to connect to a database. And usually you may have seen this before. Usually, this connection object is done through Open Database Connections, ODBC, or things like an ActiveX data object data control, ADODC. Or if you're using Java, it would be a Java database connection. And so what we typically will see is this connection object will be inside or embedded in the code of a web server. And what that does for us is it allows us to immediately interact with the database. If I can connect to the database, then I can interact with that database. So I provided the credentials, the user ID and password of the database, and then I will need to present that as a connection object. So if I'm running an IIS server, it's very likely going to be an Open Database Connection, ODBC, Microsoft proprietary libraries that are going to connect to a database. So ODBC is Microsoft, and that means that you're probably running an IIS, a Microsoft IIS, Internet Information Server, as your web server or web application. And so what we typically will see here is the inside of a table, inside of a database, there are different tables inside of here. And these are kind of like Excel spreadsheets where, the information's in columns and in rows. And so these tables inside of a database could be named something like people, places, and things. Those could be our three different database tables. So in this connection object, I will need to be able to connect to my database. And then once I connect to the database, now I got to be able to interact with that database. And what we were talking about the other day with an LDAP query, how I built that LDAP query so we could interact with a directory server. So all of these different data stores have some sort of language that if you spend a little bit of time, you can learn the language. It's very intuitive and typically straightforward to be able to utilize. And in our case right here, what I'm going to do is I'm just going to show you how we would do that. And what we typically will see is in dynamic web servers, we will use the structured query language or SQL. Come on, SQL. There we go. So we use structured query language in modern day databases that enables us to be able to communicate with that database. And this is kind of neat if you've never seen this before. If I wanted to, from the web server, make a connection and get all of the information from the people's table here, what I could do is I could write a SQL query and run it from my web server to go and pull the data from the people's table in the database. And all I would tell the code that I would write for that is select asterisk, which means all, from the people table. And what that would do is that would pull back all of the data that is in the people's table into an object that I could utilize in the web server. So the structured query language allows us to interact and search items through the database. And we kind of talk about some of these things throughout the week, and hopefully it's making a little bit more sense now that we're kind of jumping into some of the more granular things. But I talked a little bit about the other day about one of the models for access control, and it was the Clark-Wilson model, if you recall. And that Clark-Wilson really harped on what was called a well-formed transaction. And so that's basically what we're doing here. We're adhering to that Clark-Wilson model. We're creating a well-formed transaction using structured query language. We're creating an object that will allow us to communicate with the database, to be able to serve up the data to a browser dynamically. And so this is how this works right here. Let me just show you. I'm going to put this one over here and then put this one over here. So these are going to just be little tools I'm going to use for demonstrative purposes here. So just bear with me, okay? Let's say here that I am browsing my favorite bank site, okay? Whatever bank site you use over here, the banking app or banking site, whatever you're using. So as I go into my banking app, I will have an account number with my banking app. And that account number is unique to me. So it's a unique identifier that is just something that is linked back to Ben McGee. And so when I connect to this web server from my browser, I will supply the user ID and the password for the access to my banking app. So now that I'm authenticated, everything that I see inside of that banking app is now associated to my account number. Well, how does that work? Well, check it out here. If I just make each one of these its own little object right here. So if I just say, I'll put the account number up here. Check this out. I'm gonna show you how this works. So if I go here and I just say user ID, password, so my credentials. So what I would do is I would log on to the website, and right when I log on to the website, there would be a call to an Active Directory server to see if that's one-to-one verification. So does it match? Do what we have on file, does it match what that person presented to me? If so, let's authenticate it. So that's the first step. Now we got to figure out, what are they authorized to see using this software development methodology and trying to tie it all back together. So I've authenticated this user to this banking app. Now, what do I got to do? Well, I know that this user has an account number. So the user authenticates to the web server. The web server then says, okay, well, what's the account number that's associated to this user? Well, the web server would then make a database connection back to the database. And that connection would have a SQL query in it that would say, select all from people where account number is equal to whatever my account number is. So B. McGee's account number. All right. So because of that, now I have a limit or a constraint for that well-formed transaction where I've made the connection to the database. I have selected the info, or I'm asking the database to present me with a data set that's limited to just the account information for B. McGee. So the database would then jump into the people's table. It would then pull back a data set and deliver what's called a data set back to the web server. And that data set is an object that can be consumed by any developer that's using the web server. So the data object, the data set object would come back here, and then it would be presented to this user over here through what's called a constrained user interface. And so usually that's like a view, or the way that you can see the data is presented to you in a constrained user interface within a web application. And so through this process, we see how a modern day client server application works through a browser. So now it's a web application in a dynamic sense, because it has the ability to change on the fly as we go through and interact with that constrained user interface. We're pushing different buttons, you know, we're sorting the information, we're selecting hyperlinks. Each one of those click events would then make a different connection back to the database, and the database would then render back a new data set object to the constrained user interface. The developer would develop a constrained user interface with a view that's got all these bells and whistles on it, but essentially the view would take that data set object and present it in a meaningful way to that user, and have that user give the user the ability to interact with that data set. With each click event that the user interacts with that data set, what we would see is it would make another remote procedure call using structured query language and connection objects back to the database, giving us that dynamic web server or web application component. So if you think about things like your banking app, or Facebook or Instagram or Snapchat or any of these things, if you take the browser out of the equation here and we put the icon for the app in here, this is how it works. This is how it works. You're authenticated. You identify yourself. You're authenticated. Once you're authenticated, what are you authorized to see? So what view am I going to limit you to while you're interacting with my web application? And that view typically is, what am I authorized to see based off of a unique value that I can link back to you. 20, 30, 40 years ago, when we were first starting to develop these things, and even probably now somewhat, I'm sure some people are using them, we used to link that unique identifier back to a social security number. And with privacy issues, we've gotten away from doing that now. But you need something unique to be able to query or interact with and constrain the user's interface. And typically that's something that is directly traceable back to that user. An account number, a unique identifier in some way, like a user ID perhaps, or an organizational unit, a DN in LDAP would be that unique identifier. At NASA, we had something that we called the UUPIC, the unique or universal unique personal identification code, which was just a made up code that is only good at NASA, that was basically tied to you while you worked at NASA. So keep that in mind as we go through and have these discussions, because the object here doesn't need to be complex. The object can be anything. We can create objects and interact with objects however we want to fill those objects. So in our case right here, I have a data set object that gets returned from the database. Now I got to figure out how am I going to interact with that data set object in a meaningful way and present it to that web application.